everyone. Let's talk about wonderful topic of the query performance optimization. And though this is called the deep dive, it is the deep dive you can do in 20 minutes. And that is actually a big topic where you can go either deeper in, but I'll do the best I can in the time I have allocated. Let's start by thinking about database from developer point of view. My experience is there are developers which are not specifically database focused, are really looking at their database as a black box, and kind of troublesome black box at that. Right? Often database open developers will find database which something which prevents them from getting the job done because it is complicated, messy, it's often slow, and so on and so forth. But let's look at the database from application point of view, and what does it really mean to think about a database as a black box. That means from my application I can connect to a database, Zero's point, and do that quickly, and then I'm spending most time running the queries which you designed your application to run. That is where you spend most time and effort, that's where most problems happen, and that's what we are going to be focused about. So with those queries, what do you really expect? What does it mean what the database performs awesome and does whatever developer needs it to do? Well, you want to make sure we run without errors, right? Errors are bad. Then you want to make sure you get correct results from your queries. And finally, you expect them to complete within that required response time, right? To make sure what they are fast, right? Now, it is the response time which is probably the most complicated issue where a lot of time is spent there, and a lot of that also happens after the application is launched in production. So if you think about performance from again this kind of very simplistic point of view, well, if database responds to my queries correctly, the response to my queries in a good response time, then that means the performance is good. Now you can think about the database, about performance from a couple of points of view. One is you can think about response time from database point of view, focusing on queries. For example, you may say something out, this database responds on a queries 5 milliseconds in average, right? Often people talk about different latency for selects and updates and so on and so forth. But I think if you think about the business point of view, then it is different, right? You are not thinking about a database on its own in this case. It is simply one of the widgets of your infrastructure, though pretty important one. You want all your application users to have an outstanding performance experience with all their application interactions. That is what we are striving to, and a database is part of a story. One of the things what that means is we often have to be looking not at the average query performance, right? Because remember, we all want to look at the all, or at least most user interactions for most of our users, and that means, well, we don't want just to focus on the average query performance time. In many systems, you will find some percentile presented. Percentile, like in this case 99 percentile, that means what the 90% of the queries, in this case of this query pattern, they're completed at the less at the specified number of milliseconds, right? 83 milliseconds. Now it is important to know though what the query response time is not the same as a user response time and user experience, even if your user experience is highly database performance related, because you will see what each user interaction often has a multiple database queries, and during the session, during the day, users often have multiple user interactions and they don't want to have any of them particularly bad, right? If your website times out when it's was your page number 7, you are going to be pretty unhappy about the whole experience, right? Not just giving a credit, oh, my first 6 page views looked wonderfully. Another thing to consider when looking about the response time, what that tends to change over time. Often I see folks when they design the systems, right, or practices for looking at performance, they look at some very big period of time saying, well, over last week or last day the performance 99 percentile performance was X, and that is wonderful. Well, maybe you had a period of time for several minutes or something when performance was bad. Well, that is not a good user experience, all right? You want to understand how performance changes over time, because there could be a lot of either internal database behaviors, maybe traffic spikes, maybe some cloud issues which impact performance. And that impact may be limited to one of the queries, or maybe impacting all the queries of particular kinds on single host or all the hosts, right, depending on what exactly causes, and depending on that, you'll have a different strategies to fix it. In many cases, you have a choice where you want to instrument your application. Right, and that could be the database or application. And I think that is not really a very good question. It's not an or question. Typically, you very much want to have some application performance monitoring system, so you can look at the things from an application point of view, which may use multiple microservices, multiple components, right? And database may or may not be the main cause of your performance problems. But then, let's say you discovered what a database is what slows your application down. Or maybe you even discovered a particular query which is slow. This is where or was running slow at particular point in time. That is where you need their system, which goes deeply in database, and often database specific, so you know how to improve that query with a particular database. Now remember what we spoke about their business use from response times. We spoke about all users having a performance experience with all their application interactions. Now we don't quite see a complete picture of that application interactions on the database side, but typically you will have queries which corresponds to particular application interaction. And that is why looking at the all queries overall is typically not as helpful as being able to break down queries by the different query patterns, because those different query patterns also will have a different frequencies, different performance profiles, and often different acceptable level of performance you may have. For example, background activities may have substantially high tolerance for slow response time compared to some mission critical user interactive queries. Another thing to consider is what you may have multiple users on your database. This may be different services, different applications which share the same database instance, or in shared environments with often multiple tenants which share the same schema, share multiple schemas, right, or the database. In those cases, you often would have the query patterns being the same for all those different queries, different schemas, but it is possible what particular schema may be experiencing different performance profile. So here is an example with our tool, Percon Monitoring Management. Hypothetically, we have an application here which is running on multiple schemas from TPC C1 to TPC C5, right? They are all really the same query pattern and so on and so forth, but you can see here what TPC C1 having a very different behavior. It has a different average query response time and a lot different load which those set of queries generate. In this case, I would go ahead and examine what could be wrong with that particular schema. It may be some configuration issue, like for example, often enough migration job may fail on one of the shards and forget to add the indexes, or it may be something else, like index stats haven't been updated, maybe, or maybe just that is a very big shard which has been overloaded. It's often good to have an option to go even deeper and identify all the queries which hit particular table or particular collection, right? In certain cases, users talk about those as the problematic data, right? I have seen so many times saying, oh, I have this nasty table XYZ, right? And all queries I hit it seems to be problematic, right? But also the reason to do that is because many operations such as indexing, maintenance, and so on, right, is database specific. Many problems such as an index bloat can be specific to the table as well, right? So being able to see what is happening with the queries which hit particular table is often very helpful to point in what the table needs some love. Next grouping, which I find very helpful, is being able to look at the load which goes to the database grouped by the database user. That can help us to identify the service or application and as well find human troublemakers with interactive access. Right? Now, it is also a good idea to use in a shared environment to use applications for different tenants if your schema allows it, because besides the query performance optimization and kind of understanding the load, it really helps with security. Now, in this case, we all talk about the queries, but we did not really talk about the system overall. Increasingly, as we look at the systems, we want to design them as herds, sort of, not pets. And that means that we do have often many database hosts instances. And hopefully, all those database hosts, they are having the same query performance, but often enough that is not the case. And often for one reason or another, you will find some database hosts having a worse performance problem, even if sharding environment they serve substantially similar traffic, right? So being able to look, contrast, compare the query performance in different hosts, as well as a query load pattern, is very helpful. Now, last thing I will cover in this breakdown standpoint is thinking about the host where traffic comes from. Application server, web server, maybe even user's machine. In many cases, when you have multiple application servers, you kind of expect them to all more or less perform the same, right? Generate the same query load, but it may not be the case. Sometimes it is configuration different, sometimes you have different versions of a code, like for example your deployment has not worked out properly. It may be the other reasons as well, and making sure to validate what from a database standpoint all your web hosts behave the same way rather than just trusting the development team, I think is very valuable. So with that, we spoke about grouping down queries and kind of slicing and dicing that query performance. But in the end, it all comes to the question of after finding the problematic set of query or query. And then you have a question, where does that response time comes from? And response time can actually come from all different reasons. It may be data crunching, disk I/O, role locks, contentions, and so on and so forth. And I think that is one of the very important areas in the query performance analysis, to really understand what exactly query response time comes from, because otherwise you may be focusing on the wrong things. So let's consider a couple of other things as well in our journey to understanding their query performance. Now, if you look at all the queries your system is running and finding the queries which respond unacceptably slow, you may find some of the queries which are slow because they are heavy or bad on their own. There could be some other queries which are simply victims. And it's not always very easy to see one from another. For example, you may see some single row update query taking a long time, well, just because there are some other queries have taken the row locks for a prolonged period of time, right? And this is their connection to a previous question about understanding where response time comes from is very helpful, because if you understand what query response time come from row level lock, and this query just needs to lock one row, update it, and unlock it, then you would know, well, it's probably somebody else which is causing that slowdown. Another thing to consider is making sure you do not ignore invisible stuff, which may not be seen in your query profile, right? But if you think about the database from one standpoint, it serves the queries which comes from a variety of its users, but there is also some invisible stuff which is kind of going on, which can impact performance ebbs and flows. Database may have a lot of background activities, flushing dirty pages, doing some background garbage collection, and so on and so forth. There may be some maintenance operations, like you are doing backup which copies files and it may overload disk subsystem, while you don't see that through running queries on a database size. Or in a cloud, you also may have a lot of what I would call cloud noise, right? Like various things which are happening and which are completely uncontrolled and often invisible for you, right? As you make a hypothesis about what's maybe going on with your queries, think about that. Now, I would mention how you want to get the data about queries. And the mistakes I often see here is not getting some representative sample of your queries, or processing all queries if you have enough power to do that, but let's say focusing only on the slow queries. The problem in this case is, of course, you are only focusing on outliers, and while in many cases fixing those worst queries is a good idea, it may not be enough, and that actually may not be the biggest problem for you. Right? In many systems, there are some even well-tuned systems. There are just some outliers, right? One query in a million happens to be slow for whatever reason, right? But it is the other queries where tuning efforts are much more helpful. Now, if you want to learn more about this topic, actually, I think the very good book to read is not really the technical book about a database or computing at all, but the book, The Goal on Theory of Constraints. It really helps you in a very practical way to understand that all the idea about processing queries and database and like requests in attack systems in general. I hope that was helpful. It will help you to get your performance under control, and so you do not will not need to resort to the scaling via credit card, which is unfortunately so common way, and especially in the cloud. With that, it's all I wanted to say, and thank you.